Today we're going to be talking about section 1212, which is about circles. A circle is defined as the set of all points that are the same distance from a given point. Okay, in the case of a circle, the given point is going to be the center of your circle. So, for example, say we're given the point 2, 1. All right, so we're going to graph that over here. So there's the center of our circle. Any circle we know has a radius. Say our radius goes out to here. So there's my radius. Well, the circle is made up of all of the points that are that same r distance away from our center. We'll call the center C. Okay, so if we plot out all of these points that are the same distance around, enough points would eventually make a solid line, and that is where the definition of our circle comes from. All right, so there is a equation that we use when we're talking about a circle, and the standard form for the equation of a circle is parenthesis x minus h to the second power plus parenthesis y minus k to the second power equals r squared. And specifically, the center of the circle is at the point h, comma, k, and r is our radius. All right, so let's take a look at an example of what this looks like. Let's say we have this example. We want to know what is the equation of the circle with center at -4, 3 and a radius of 4. All right, well, all we do is we take our standard form, okay, which again is our x minus h squared plus y minus k squared equals r squared, and I'm going to plug in my values. All right, well, our center, remember, is of the form h, comma, k. So in our case, our h is -4, and our k is 3. So that's what we're going to plug in for those values. So we have ax minus rh, which in our case is -4. And that is all to the second power plus y minus k, which in our case is 3 And again, that is all to the second power. R is our radius. So we plug in our radius that we're given of 4, and that's squared. Now we just need to simplify this. Well, x minus a negative 4 becomes x plus 4 squared plus y minus, no extra sign there, so it's just y minus 3 squared. And 4 squared, well, we know 4 squared is 16. So the equation of the circle with the center at negative 4, 3 and a radius of 4 is going to be x plus 4 squared plus y minus 3 squared equals 16. Right there. Okay, we can also use this when we are talking about transforming a circle. So our standard form is our x minus h squared plus y minus k squared equals r squared. But there are a lot of occasions when we would talk about a circle that is actually centered at the origin. Well, if I'm centered at the origin, then that center point is 0, 0. So my h and my k are just 0 and 0, which means my equation becomes x squared plus y squared equals r squared. And that is a circle centered at the origin. And we can use this fact to solve problems like our next one. Okay. So this example says, write an equation for the translation. Translation is just a fancy word for move of x squared plus y squared equals 9. So this is simply a circle centered at the origin with a radius of 3. Because remember, it's our radius squared. 3 squared is where we get the 9 from. So write an equation for the translation of this circle by 4 units left and 3 units up. And we want to draw the graph. All right, well, again, if our original starting is at 0, 0, and we are transforming this 4 left and 3 up. Well, if I start at 0, 0, 4 left, well, we know left and right is our x. If I'm going left, I'm negative, so my new x is negative 4. 3 up, well, up and down is our y. If I'm going up, that's positive. So we're going up to positive 3. So our new center is at negative 4, 3. So if we want to rewrite this equation, again, we have an h and a k, and we're just going to plug those in. So we have x minus our h, in this case is negative 4, the whole thing squared, plus y minus our k, which is 3, squared, equals our radius squared. Well, our radius didn't change. We didn't change the size of the circle when we moved it, so our radius is still 9. If we simplify this, x minus a negative becomes plus 4 squared plus y minus 3 squared equals 9. Now we can sketch this graph. I am going to try and add a graph in here real quick. Okay, here we go. Make this turn out a little nicer. So we know we have a center at -4, 3. So 1, 2, 3, 4. 1, 2, 3. So our center, you know, 1, 2, 3. There we go. Okay, a radius of, again, we have a 9 there, but remember that 9 is equal to our radius squared, since the equation always equals r squared. So that means our radius is going to be 3. I would take the square root of both sides. So from this point, I'll count out 3. And I'll just do that in the easiest directions. 4 straight out. And then we'll connect our dots. So there's a semi-round circle with a radius of 3, centered at -4, 3, shifted from the origin. All right, the final types of problems that we are going to look at here is when we are given the equation and we need to identify what the center and the radius are. All right, so for example, what is the center and radius of the circle with equation x minus 16 squared plus y plus 9 squared equals 144. All right, well again, we want to think about our standard form, which is x minus h squared plus y minus k squared equals r squared. And we are trying to identify what our h, k, and r. H and k will be our center, and r will be our radius. Well, in our equation, we need to have 2 negative signs in front of our h and k. On the first part, the x minus 16, we already have that. So I don't have to do any rewriting on that one. X minus 16 squared plus, okay, but with the y, we have plus 9. Well, we know we want that to be a negative. And as we kind of saw in those previous problems, if it's a plus, then it must have been minus a -9 squared. Okay, 144, well, that is the square of your radius. So we want to think of the square root of 144, which is 12, and that would be 12 squared. So now we can pull out our h, our k, and the r. So in this case, our center is at 16, comma, -9, and the radius is 12. Okay, that's all we're going to cover on the video for today. For the rest of class, you have a worksheet that covers these topics that you can work on, that you'll turn in by the end of class. If you finish with the worksheet and you still have time left in class, you may work on Math Excel Assignment 7. See you guys on Tuesday. Have a good long weekend.